Our team consists of 6 members of varying skill set and backgrounds. We have 3 members from KBR, Richard Hill, a data modeller and applications developer, Nicholas Lampton, a business intelligence analyst, and Mark Roach, a data insight analyst. We have 2 members from Alpha Plus, Malik Hammond and Abby Fielding, both project managers, and Will Raggett from Oxford Instruments, who is also a project manager.
The task we were given was to come up with an efficient and ultimately useful way whereby we can track lessons learned and continue to monitor them going forward, ensuring that they are constant, being updated, accessible to a wide audience, and most importantly, actually used to deliver future projects more efficiently and effectively. The aim of our solution is to create a tool which can produce this result based on a number of considerations. We firstly looked at the data quality of the example data that we provided and then created a tool which would focus on the user input, accepting, handling, and action tracking. Then the result dashboards portray the results in a visual way, which companies can use it to easily monitor the live situations of lessons learned and recommendations.
So the interface that the user sees is the most important part of ensuring the data quality is good and validated. In cases where there could be ambiguities, we validated the data with the use of drop-down boxes and selected options. This reduced the difficult task of extracting data from free text entries and invalid data types. The other critical point to make is that all the fields must be completed in order to add a new lesson learned. This also applies in the same way to editing an existing lesson and adding new or updated records. We have created a process flow which uploads all responses into our data model. With an approximate completion time of 7 minutes, the form has been designed to ensure that the user does not need to fill in a lot of unnecessary information, taking up time and resource.
Screenshot. The result of our solution provides a much easier way of tracking each lesson learned and the associated progress. Each field is fully complete and data cleansed. We have also captured important fields such as priority, the action flag, and outcome visually. This makes it more efficient for anyone looking at the data to see which lessons learned need action. We have ensured each lesson learned has an action owner so that a sense of responsibility is applied to each lesson learned and that subsequent updates are also assigned. The follow-up frequency is also imperative as this highlights the next date at which an update action must be taken, and if it isn't, it is clearly marked with the action flag, and an email will be sent to the action owner. The email implementation is not currently added but will be with additional time. The target completion date also identifies a time frame within which lesson learned actions should be completed, with no further recommendations required, but with future steps still required to ensure lesson learned still applies going forward. Further implementation we would add to our solution is the filtered view specifically for projects. This could either be achieved by creating roles within Power BI or by producing a paginated report where the user would filter to their project before viewing the data.
All right, so to enhance basically the program, what we thought about doing is a Python code proof of concept that uses natural language process semantic similarity to be able to put a prompt in to recognize similar lessons learned and their associated recommendations within the database. We think it will be a very powerful tool for the users to be able to quickly benefit from the wealth of the accumulated lessons to be learned. So the 3 questions that we were given were, what are the limitations of reproduced data sets? So the data set was limited and there were several important required fields that were not captured, and basically we had to go through to be able to do some data cleaning exercise that should be carried out, and the data input interface which is being used on the existing data set should have validation in place to check that the new records are checked for errors and nulls and fully compliant with what is being requested as an input. Second question, that how would you categorize the qualitative text to enable the analysis lesson learned? The category qualitative text would be divided into the description of the lesson and associated recommendations with NLP algorithms in place to enable analysis within. Is the MS form submission sufficiently anonymized to enable open and honest feedback, and how this would be implemented was the third question. During the form submission, we do not require any sensitive data. Although we have taken these precautions, there is a chance that personal data could be included within the free text field. Should we need to, we would add steps during the ETL process to anonymize specific words and phrases, as well as instructing everyone to avoid putting sensitive data and explain the risks.
We also reviewed our solution against the 5 pain points. We have built a feedback loop into the solution to track the usage of the lessons learned logged in the repository. By using an app interface, the user is guided through the process, ensuring that all key pieces of information are captured in a consistent way. All the lessons learned are captured in a single database, covering all participating companies or organizations. We have developed an easy-to-use app which will be phone-friendly, allowing the user to choose how and when they want to interact. At any stage during the project, the user is able, via a button on the input form, to click a button to download a report detailing all lessons learned, presenting the information in a user-friendly way.